Welcome to myprojectbazaar.com. Let us see the demo of keyword query routing. Keyword search is a new technique for searching linked data source on web. We propose to route keywords only to relevant sources to reduce high cost of processing keyword search queries over sources. We propose a novel method for computing top-K routing plan based on potential to contain results for given keyword query. We employ a keyword element relationship summary that compactly represents relationship between keywords and data elements, mentioning them. Multi-level scoring mechanism is proposed to computing the relevance of routing plan based on scores of level of keywords. Data elements, element set, subgraph that connect these elements. Experiments carried out using 150 publicly available sources on web showed that valid plans that are highly relevant can be computed in 1 second on average on single PC. We further show routing greatly helps to improve the performance of keyword search without compromising its results quality. Keyword search is a technique for finding an item with specified properties along a collection of items. Keyword query is a query that the users entered into a web search engine is to satisfy their needs. A keyword query routing is a technique that routes keywords only to relevant source to improve performance of keyword search. The graph structured data consists of set of ordered pairs called edges of certain entities called nodes. Resource description framework is a family of World Wide Web Consortium specifications. We are using keyword query routing for keyword search over a large number of structured and linked data sources. Routing keywords only to relevant sources can reduce the high cost of searching for structured results that span multiple sources. To the best of our knowledge, the work presented in this paper represents the first attempt to address this problem. The existing work uses keyword relationship collected individually for single database. We represent relationship between keywords as well as this between data elements. They are constructed for entire collection of linked sources, then grouped as elements of compact summary called set level keyword element relationship graph. Higher style ranking has been proposed to incorporate the relevance at the level of keywords to go with increased keyword ambiguity in the web setting. We employ a multi-level relevance model where elements to be considered are keywords, entities, mentioning these keywords corresponding set of entities, relationship between elements of same level, and interrelationship between elements of different level. We implemented the approach evaluated it in real setting using more than 150 publicly available datasets. The results show highly relevant to user information. We construct multi-level interrelationship graph for entire collection of sources, such as keyword relationship graph model both relationships that are within and those that link between sources. Keyword relationships are stored together with elements they contained in and are associated with source information. In particular, we construct the element level keyword element relationship graph that constitutions are relationship and every element captures the besides a graph. Both keyword and element was mentioned using entity keyword relationship graph. While extending keyword relationship like this can be solved, keyword query routing problem. It has one essential flow, just like keyword search approaches. Let me start the demo of the project. First of all, we have to run the home.java. Select the geographical.owl file. This is the Anthology web language format. This is the OWL file. This is the resource description framework format. Next, we have to derive the RDF class and RDF properties. Then we have to get the data type properties and object type properties. Then pass the state properties and city, river, high point, low point, mountain, road, lake. Then process the state object, city, river, high point, low point. So process is 100% completed. Next, we have to store the values into the SQL server. This is the state object, city, river, high point, low point, mountain, road, lake. First of all, we have to give the input. For example, Alabama. This is the two level, set level and source level. Set level is the attribute level, source level is the combination of attribute and database. In set level, we have to find out the relationship between the keyword and the attributes. Alabama is the keyword, state name is the attribute. This is the list of relationship between keyword and attributes. In source level, we have to find out the relationship between keyword and attribute and source level. In this frame, we have to find out the number of paths between keyword and the source. The state has the more paths. In this frame, we have to find out the ranking between source. Finally, we have to find out the relevant source for given keyword. Thank you. This is the comparison between execution time for existing and proposed system. We have take the parameter time for compare the existing and proposed system. Existing system is the Steiner tree and proposed system is the multi-level interrelationship graph. Thank you. Thank you.